Now we will introduce a short prototype of what this training module will look like. You will have two options. You will be able to go down the training modules and learn some of the content knowledge, and you'll be able to go down that path. And then you'll also be able to use a PBL activity where you will have interactive quizzing and hands-on experiences to actually be a practitioner and use some of these design guidelines to help you create a lesson that you will actually teach at the end of these 9 sessions. So let's look at some of the training modules. You'll be guided through with an interactive character to make it very personalized. You will be introduced to the 5 design guidelines as this interactive character is instructing. And here we can see we have an interactive slider which shows us the guidelines. We have 5 of them. We can look at guideline 1. It's use robotics technologies to facilitate learning and not as a primary source of content knowledge. This is an important fact that we are actually going to be learning mathematics, not just about robots. Robots are just the tool to facilitate the learning of mathematics. Let's continue on. Now we can see that we have some rationale for why we've chosen to highlight Guideline 1 as an important integration strategy when actually integrating robots into your PBL curriculum. Now let's go back to the introduction page and we'll look at some of the interactive PBL activities.
Welcome. Read the instructions below and let's get started.
And now here you have an interactive robot actually guiding you through some of the activities.
First, let's do a quick review. Answer the question on the next slide.
For now, we will reinforce some of the content knowledge we learned through the modules. And we can see we have an interactive drag and drop activity where we have to highlight the correct design guidelines. If they are incorrect, they will be rejected, or if they're correct, they will be absorbed into the box. This is just a type of reinforcement activity. And then after this activity, it would go on and provide you with a hands-on activity where you will actually create a lesson, use some of these design guidelines within your lesson planning, and then teach this lesson to other students within your sessions. I hope you join us and use this training module to learn more about the integration of robotics into a PBL curriculum and really just learn about teaching mathematics in a new and engaging way for both you and your students. Okay, so we are back at our home page for our training modules. As we work through the training modules, which will give us the 5 design guidelines of how to integrate robotics into our curriculum, and we learn about how actually to integrate them into a problem-based learning curriculum and create some engaging activities. There's also another aspect of the robotics integration that we need to focus on, and that's programming. It's its own separate entity, but they work in tandem, robotics and programming. And it's actually a very important process, and it's actually a great way to integrate mathematics into the robotics integration because programming is so susceptible to those mathematics concepts. So let's look at some programming facts. Pre-service teachers in Scratch-based instruction had significantly better understanding of basic computing concepts. Scratch-based instruction was useful in constructing a more meaningful learning environment. And the application of the Scratch program improved school performance and student motivation significantly. And research results indicate that with the use of Scratch language, students get better grades and are more motivated. So that Scratch language, that Scratch is that free software for drag and drop programming, but it is a language for students to use. It's a coding language. So what is programming? This is what we actually need to kind of establish with teachers before they're comfortable moving on. We want this process to be very non-threatening and not very stressful, so we're going to start at the beginning. So the definition of programming would be to provide a computer or other machine with coded instructions for the automatic performance of a particular task. A lot of people think about this as an input or an output. And there's a lot of programming tools that you can use. Most of them are free that are specifically used for the K through 12 educational realm. So we have code.org, Hackety Hack, and some others like Alice and Stencil, but the one we're going to use is Scratch. It's a free online web tool that actually has a lot of great softwares and resources for teachers themselves and for students. But before we do that, we're going to look at the types of programming. A lot of people, and especially teachers, hear about programming and have anxiety about it because there are so many um, different types of programming, a lot that are used for just the computer science discipline, but there actually are some types of programming that are used are specifically for education. There's the basic type of programming, which a lot of you may see where you actually need to learn a little bit more about coding than you would if you were to use the Logo or HyperTalk. Logo was made in the 90s, and it was one of the first computer program tools used for education. And it's a pretty simple tool, but it's not as user-friendly as the drag and drop, the HyperTalk that we see on the far right. And that one is very user-friendly. It kind of combines Logo and Basic so that we can actually integrate content, so any STEM content, into this program pretty effectively. And Scratch, which we will be using, is this HyperTalk drag and drop computer language. So how can you use it? That is probably the biggest question for teachers, both pre-service and in-service teachers. And what's our main goal for kind of integrating it into our elementary school curriculum? We can see it used a lot in high school curriculum, but how can we integrate it into an elementary school curriculum without it being taxing on pretty much our profession and our time day in and day out? So understanding how to program a computer using one of the many programming languages in the world, either to solve a math or science problem or to create interactive apps, games, and experiences for our students. So I'm going to give you 5 steps, kind of 5 tips, how to integrate programming into your curriculum. So you want to get connected. Find a software that connects coding and programming to your curriculum and standards. There's a lot of tools out there. We do not need to kind of recreate the wheel. There's already the tools that kind of connect our content to the programming software. So creating a one-to-one classroom is not necessary. Every student does not need their own device. Programming is a language, as we talked about before, with our theories and why we substantiated using programming in our curriculum. So it does not need to be done in isolation. So collaboration and communication between teachers and students is important. You need to trust your students' ability. As we all already know this, but young students can do much more than we think with technology, and the exploratory aspect of coding is an important part of the learning process. Don't try it alone. There's forums, parents, colleagues, administration. They can all be your support system. And trying something new in the class room, we all know cannot be implemented successfully without support. And also make it fun. Make it fun for you to teach this material, and also make it fun for your students. There's endless coding software and apps out there, and they're all age appropriate. So programming is cool and fun, but what does it actually provide our students? It's not just an engaging computer game, but it actually does leave some long-lasting effect on our students. It helps build the skill sets of logical thinking, problem solving, persistence, collaboration, and communication, while also easily being integrated into a mathematics and science curriculum primarily, but it can be used for the arts as well. So as we would start off with any type of educational lesson for our students, we need to scaffold knowledge. We need to scaffold some prior knowledge, or we need to provide them with knowledge from the beginning so that they feel comfortable moving forward. We would do this same thing within our training modules, where we would give teachers an easier activity to help them get started with programming, even easier than anything that Scratch could provide them. As you could see, we're going to call this a simple Scratch activity, but you would have to move the robot with a drag and drop type activity, just without as many bells and whistles as Scratch would have. So it's much simpler for the teacher to progress and feel non-threatened with programming, where you would move the robot to get the oil. You can see that there's a key for 1 foot, and if we would like to, the first move would be move 1 foot forward. We can drag and drop. Then we would also need to see that the robot will have to turn to follow the line. Now we could either have it turn right 90 degrees, or we could go back and we could have it turn right 45 degrees, but then we would also have to have it turn right 45 degrees so that it would equal 90 degrees and then progress. And you can always go back and check, and the robot would follow the line and actually reach each point. So you could check as you go through. You could set it all up first and then check. You could also see that the robot may have to move backwards at a certain point. You could either have the robot move forward 1 foot, and then we're going to go right, and you could either have the robot go all the way backwards, or we could have the robot turn to 90 degrees, so 90 degrees and 90 degrees. This would be one of the force steps. Would then turn at 180, and it could continue to move forward. So you can either have it move backwards and move forward. So you can see how this could deal with degrees and angles, and teachers can actually see a simple, applicable way to integrate this type of drag and drop coding within their curriculum right off the bat, and they're not threatened by the process of programming. We would then actually have the teachers navigate to Scratch for Educators to complete their very own activity and create their own activity that they could implement into their classroom. You can see in the bottom right, this is the Scratch platform. It's a little more in-depth from what the simple Scratch activity that we would create. So we're scaffolding for these teachers and giving them a positive experience with programming before they even attempt to think about integrating it into their curriculum. And in tandem, we will always go back and we will go through all 3 modules and at the end incorporate them all together so that teachers will feel comfortable integrating robotics and programming into their PPL curriculum and hopefully having success with it.